Well, dear students, good morning. In this video, I am going to tell you about laws of radioactivity. In the last videos, I told you what is radioactivity, and I also explained why the radioactivity takes place and different type of activity. I told that heavy nucleus decay into lighter nuclei by emitting three types of radiation, alpha, beta, gamma. And I explained the scheme of decay is also there. Now, how fast the activity takes place, how slow it takes place, that is learned from law of radioactivity. Radioactivity, dear students, is totally statistical in nature. Statistical in nature. We generally, as students, do not understand the meaning of statistical. Radioactivity in nature is statistical in nature. Why? How? What does it mean? Actually, we cannot tell which atom will decay now, which will decay later, which will decay after 6 hours, which will decay after 10 hours. This is not possible to tell. So we study the decay behavior of a given certain mass of radioactive element which has a large number of radioactive nuclei. You know, I many times have explained you mole, and 1 gram atomic mass of element, 1 mole. For example, if you take 235 gram of uranium, 235 gram of uranium, that is equal to 1 mole, and that has 6.02 10 to the power 23 atoms. So big number of atoms are present in small mass. So which atom will decay at this time, which will decay tomorrow and day after tomorrow, we cannot tell this thing. So we study the decay behavior of a group of radioactive nuclei present with us. Statistical means statistical. You have learned mean, median, mode in class 10 also, statistics. So by taking average, by taking mean, median, mode, we can tell the characteristic of the given data. Similarly here we study and we can derive accurate law by applying laws of statistics. Now every law of radioactivity is derived from the concept of probability of decay of nucleus. Probability means possibility, how many times a nucleus can decay per unit time, that is called probability of decay. Probability of decay. Actually, different authors use different methods, and when I was student, I could not understand what is the meaning of all these things, and even I have noticed in my teaching line that some meanings are not clear to a teacher also who have experience of 10, 20, 15 years. Because I had interaction with many people, the professors of degree college, teachers of primary school, junior high school, inter college, etc. Only it needs meditation to understand. You think of what you are doing, only then. So law of radioactivity, so I write here radioactivity. Radioactivity is totally स्टैटिस्टिकल, ये सेंटेंस में लिखूंगा, स्टैटिस्टिकल इन नेचर, दैट इज we cannot derive any law of radioactivity by the study of a single nucleus. Actually, in chemistry, and physics also, you can tell physical and chemical properties of element by studying one atom. By suppose sodium atom is there, it has 281. Any element having one electron outermost orbit is most active. You can tell everything about sodium or calcium or magnesium by knowing the property of one atom. One atom represents the whole characteristic of, but here a single nucleus of any radioactive element does not define the radioactivity and other properties. So we have to study we study the decay behavior of a group of radioactive nuclei, of an element. It is true that radioactivity is different for different elements. So by studying the decay behavior of group of radioactive nuclei of given element, and we can derive accurate laws by studying the decay behavior of a group of radioactive element. Radioactive element. Now, please don't get frustrated that I am telling the thing again and again, same thing. But this is the only method and easy method what I am telling you. The derivation of law of radioactivity of an element is based on the probability of decay of a nucleus per unit time. This is important what I am telling, dear friend. This probability of decay of a nucleus per unit time is called decay constant. Which is given by lambda. What does it mean? It means the radioactive nucleus of element, one nucleus of radioactive element decay lambda times in 1 second. Lambda decay constant means probability of decay of nucleus per unit time. Means if lambda is the decay constant, it means a nucleus of radioactive element decay lambda times in 1 second or per unit time, whatever unit you choose, that is your choice. So if we have n t for time, at time t we have n radioactive nucleus. N t means at time t we have n radioactive nucleus. If we have n t radioactive nuclei of an element at time t, then the number of the number of radioactive decay taking place in small interval of time dt. Time interval dt taken very small, so that we can assume that radioactive nuclei does not change, though changes. I have told many times, if we have 10 to the power 10 atoms and 10 atoms get decayed, so if we subtract 10 from 10 to the power 10, so it is nearly 10 to the power 10. That is the meaning of time small. I generally keep on telling the meaning of large and small. So the number of radioactive decay taking place in small interval of time dt from the given sample. I write dn modulus represent number. बताओ why I have used modulus. So lambda n into t, it is the number of decay taking place from anti-nucleus per unit time. Lambda decay constant. Lambda decay constant means a nucleus decay per second. Lambda time. So n decay, and if we have n atoms, then there will be lambda into n decay per unit time. Now in time dt, this simple unit method. here modulus dn is taken just represent number. This is because dn means n t2 minus n t1. And T1 the radioactive nuclei present time T1 and T2. So later time the number of radioactive nuclei will be different. That gives the number of decay. The difference of the radioactive nuclei present at time T1 and at time T2 gives the number of decay. So we can write this equation as minus dn equal to minus n nt dt. Minus sign means dn is negative, so we have taken this side. Dn I am telling you is equal to nt2 minus nt1. nt2 are the radioactive nuclei left at time t2 and nt1 the radioactive nuclei at time t1. So nt2 less than nt1, so difference will be negative. Please try to understand this equation, how I have written this equation. Lambda is the number of radioactive decay taking place per second or per time from one atom, from one nucleus. So if there are anti-nucleus, then it is lambda anti, and in time d to this. Now here, there is a little trouble for students of biology, but you learn it. Because now it is not easy to explain all the things, but the things are which are true we have to assume. So we write that dn upon nt equal to minus lambda and lambda dt. Lambda dt वही आ गए नंबर ऑफ रेडियोएक्टिव न्यूक्लियाई पर यूनिट न्यूक्लियस इन टाइम dt लैम्डा dt. सिंपल है मामला, थोड़ा अर्थमेटिक समझिए. इंटीग्रेटिंग बोथ साइड और इंटीग्रेशन dn अपॉन nt इज इक्वल टू इंटीग्रेशन माइनस लैम्डा dt. और I have told you many times that integration dx upon x. Biology students don't go that way. We are not knowing the mathematics, which we have to know. It is log base ex. Difference integration of dx upon x. So it will be written as log base e and t. Log base e and t is equal to minus lambda t plus c, where c is constant of integration. The value of c can be obtained by applying initial condition. By applying initial condition, c constant of integration. The value of c can be obtained by applying initial condition, that is at t equal to 0. Initial means, now what is t equal to 0? ये भी problem है. T equal to 0 means when we start observing the phenomena. ये नहीं कि जब एलिमेंट बना था. When you enter lab and start your watch, that is t equal to 0. And t equal to होगा n0. So putting t equal to 0 in this equation 1, and t as n0. So from equation 1 we get log base E and 0. And given number of radioactive nuclei present with us in the starting is equal to minus lambda into 0 plus C. So C is equal to log base E and 0. Many students keep on thinking what is E. I have told in one video exponential series, general mathematics used in physics. There is one video. I may tell again here. So putting the value of C equation 1 we get log base E and T minus lambda T plus log base E and 0 or log base E and T minus log base E and 0 is equal to minus lambda and T. You may pretend that we don't know what is log, but now dear students you have to learn. Our educationists actually are much worried what to do because of knowledge explosion. Many things are deleted from syllabus and you have to learn it separately yourself. Take help of books. You are supposed to be wise enough. You can understand every function of the mobile phone. But you can't learn this. You have to learn this thing. Nobody is going to teach you the function of telephone, but you know everything about this. So there is formula of log. What is that? Okay, log m minus log n is equal to log m by n. So it is here log base E and T upon n0 equal to minus lambda T. Log base E. Again, from definition of log, we have learned okay if a to the power b equal to c. If definition of log, then log of c on base a is equal to b. For example, if I write 10 to the power 2 equal to 100, so log of 100 on base 10 is equal to 2. This is example. This is definition of logarithm. If a to the power b equal to c, then log of c on base a is b. That is this. 10 to the power 200, the log of 100 on base 10 equal to 2. So we can write it, it is in this form, so we have to write in this form. So we get it as, because it is base E, so we get nt upon n0 is equal to e to the power minus lambda t, or nt is equal to n0 e to the power minus lambda t. Now you may be thinking of what is this equation, what is the conclusion from this equation. Lambda, हमने बताया क्या है, what is lambda? Lambda is decay constant, that is number of decay per unit nucleus per unit time. What is E? I have told you E is exponential series. E in fact is equal to limit n tends to infinity. यानी कि बड़ा नंबर है 1 plus 1 upon n to the power n. ये हमारा इतना सारा E है, and I have derived its value come out to be 2.82 I think. नहीं भूल गया. Value of log base E, sorry, value of E 2.82. Yes, it is 2.72 है, सॉरी 72। तो अगर ये पावर ऊपर है, मान लैम्डा टी, इट मीन्स दिस 1/e⁻λt। So as t increases, this value decreases, and if we plot the graph between t and nt, so it is n0 number of atom here, it keep on decreasing exponentially. The curve come like this, and this equation nt n0, what is this telling you? This is called, I will call it, this is called Rutherford Soddy law. Now nt is the number of radioactive element nuclei left at time t, and 0 is the initial number of radioactive nuclei. Lambda decay constant. Graph is like this. There is you see n0, 0. It will be here n0/2. So time corresponding to this is called t half. Half life. I will discuss in next video. Please watch this video carefully and try to understand. Read again and again, watch again and again, and imagine yourself what I have told. Without imagination you can't help. Please like the video, share the video, and ask your friend to subscribe my channel. Thank you.